right, we're on our final stretch. We've got T6 here, solve systems of linear inequalities by graphing. So basically you are graphing more than one line and you're shading what's common between them. That's all you're doing. So solve the system of inequalities by graphing. We've got y is less than or equal to -7. So let's come on down here to -7. We know that our line is going to be solid because of the inequality symbol. Then we've got y is all values greater than or equal to -10. So click your green. I've done this wrong again. Okay, just do this one and then go back here. So I've got the solid line for y is less than or equal to -7, and I've got the solid line for y is greater than or equal to -10. Well, if I were to shade in here less than 7 and shade in here greater than -10, then the portion I would shade would be between them. So I'm going to shade this portion right here. Once I've shaded, I submit. Alright, so this time we've got x is greater than 8. Alright, so now this time our line is going to be dotted because we don't have an equal sign under here. So nothing on this line will satisfy this inequality. Then we've got x is less than or equal to +10. So we go over here. We're on 10. It's going to be solid. Now if all values of x are greater than 8, that means in this area. And if all the values less than or equal to 10 are in this area, that means we shade between them. Alright, so here we have y is less than -2. So let's go to -2. We know that our line is going to be dotted because we have the less than symbol, not less than or equal to. Now on this one, we have y is greater than -8x plus 4. So this is a slanted line. So we're going to start at 4. We know it's a negative slope, so it's going to fall from left to right. So we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, and to the right 1. And again, it's going to be dotted as well. Now here you kind of have to be able to see what's going on. Right now it's saying that y is less than -2, so you would shade all of this. But then it comes along and says y, the second line, y is greater than -8x plus 4. That means that everything above this line should be shaded. So the only portion they have in common is right here in this corner. Now you may have to rewind this part because I think this is the most, not difficult, but you have to be able to see it, and sometimes it helps to draw it if you need to do that. Alright, let's do our next one. Y is greater than 2. So here we have 2. We know it's a dotted line because we have greater than, not greater than or equal to. Next we have y is less than or equal to -4x minus 3. So we know we start with our intercept at -3. We know it's going to fall from left to right. So we're going to go down 4, 1, 2, 3, 4, to the right 1. And now this is where we start comparing. Y greater than 2. So everything up here would be shaded. And then y is less than or equal to this line. So everything below this line would be shaded. So it has to be above this dotted line, but below the blue line. So the area that we would shade would be right here. Alright, now we have x is less than or equal to -5. So here is -5. And since x is less than or equal to it, then that means everything on the left would be shaded, including this line. So just imagine all of this is blue. And then we have y is less than or equal to -2x minus 3. Well, let's go to -3. We know, I did it again, didn't I? Okay, there we go. negative 3 is our y-intercept, and we know it's a negative slope because of the negative in front of 2, and our slope is negative 2 over 1, so we're going to go down 2 and to the right 1. And right now we're saying that all the values of y are less than this line. In other words, they're below this line. So think about this. This x is only from this point over. This y is from here down. But where do they have points in common? That's what you have to think about. So if I can only go to the left of this line, even though I can go below this line, they don't have anything in common until they get in this area. So we're going to shade this area. I think we'll do a few more. Let's see where we are. 47? Okay. So here we have y is greater than negative 3 plus 3. So go up to 3. We know it's a negative slope, so we're going to go down 3 to the right 1. It's going to be a dotted line because of the inequality symbol. And we know that y is greater than this line, so it means everything above this line would be colored. Let's go ahead and do the other one. We are at negative 4, and it's a positive slope, so it's going to rise, go this way from left to right, so we're going to go up 7. So it would be 1, 2, 3, 4, 5, 6, 7, and over to the right 1. And now it says y is all values less than that. Okay, this is where it gets really, really tricky. Now we didn't have any problem at all doing y is greater than the green line. But y is less than 7x. Do we shade above? Do we shade below? Well, in this case, I would say use a test point. What can we use? Of course, 0, 0. We want to see if on this blue line we should include 0, 0. And actually we could test both. So we're going to test y is, cross that out, y is greater than negative 3x plus 3. And we're going to test y is less than or equal to 7x minus 4. And we're going to test 0, 0. So 0 greater than negative 3 times 0 plus 3. 0 greater than 3, is that true? No, it's false. So we are not going to shade the area that includes 0, 0, and we were right about that. We said we're going to shade above the green line. So let's test here. 0 less than or equal to 7 times 0 minus 4. So 0 is less than or equal to negative 4. Well, that's false as well. 0 is greater than, so we're not going to include the portion that has 0, 0 in it. So we're going to shade on the opposite side. Now keep in mind, when you're shading, you just can't shade anywhere. You have to shade the area that they have in common. So right now, we would have shaded all of this for the green, but only this portion for the blue. So what they have in common is over here. Good night. I'll see you later.